I felt that the easiest way was just to do a recording of my name. It's Uduak Daniels. I've worked across a little bit of background about me. I've been doing cybersecurity but for about 17 years, from way back in the early 2000s. I've worked for about 11 of those years with large asset owners. I've done consulting too worked with a large Big Four. One of the things I like the best about what I've done over the years is just helping pretty large oil and gas companies to figure out how to be able to structure cybersecurity throughout their plants and facilities, hold a few certifications of interest. I'm currently doing a lot of standards and procedures in cybersecurity committees, and also part of the ICS Secure Technical Steering Committee when I get a chance to take a look at that. A bit of my presentation overview today is work through a few definitions. A lot of people don't really understand what it means for a facility, what the life cycle is like. We are talking about these cybersecurity attacks in a plant and across different verticals. But what does that actually mean? How do we explain that? And what does lifecycle, automation lifecycle is? And what are the different phases? How does that compare with the security lifecycle? We'll take a look at security levels as it's defined by our standards, reference organization 62443. And we'll look at, I want to zoom in a little bit. There's the whole life cycle about cybersecurity. 30 minutes won't be able to take us through that, all of this but we would focus on the operation and maintenance phases, where we typically see a lot of the drama associated with breaches and investigations and testing and assessments. And that's typically during those phases. We'll talk about something that's the achieved security level based off target security levels that are defined as part of risk assessments when facilities are designed and built. So I'll just jump straight in. The lifecycle engineering is just basically looking at maximizing and utilizing your industrial automation control system that you've designed and specified as part of your build, but without impacting safety and reliability. And obviously safety and reliability is the key words there to focus on. So in as much as we want to utilize these facilities and maximize and increase the life cycle, we want to ensure that that's done in a safe and reliable way. Lifecycle extension, from an engineering perspective, it looks at how do I maximize the return on investment when I've built a facility, looking at the different components and systems as it goes through the life cycle, and you hit places where you're dealing with obsolete systems that have reached end of life. How do I get better benefits? How do I get return? How can I extend the life of these facilities, especially when they're billion-dollar investments? Security lifecycle. Now, this is where we come in, where we're looking at from a cybersecurity perspective. What are the security measures that are introduced throughout the life cycle of the automation system? And how do I realize that in a particular facility? And so looking at the security measures and when those countermeasures and measures are applied, how long they last for, and at the different parts they relate throughout the life cycle. Security level, so 62443 content definition 1-1 talks about security levels being the level of confidence you have in a specific system under constructions, and that's all centered around the zone and conduit for a specific system, to ensure that they're free from vulnerabilities and that are built systems, and also systems during their life cycle when their operation and maintenance phases are at play. End of life, I probably I won't spend time defining that. We know a lot about end of life. Target security levels, desired level of security of a particular system. An achieved level is whether you actually achieve the targeted level of your system during its operation and maintenance phases. So a couple of definitions there. I always like talking about stakeholders. In my experience and across the industry, we kind of seen that these interactions between stakeholders, vendors, and different product manufacturers, and the roles that they play within a facility are key to ensuring that cybersecurity requirements, those functional requirements, are are baked in from the design phase all the way to the decommissioning. So these are some of the stakeholders at play: product manufacturers, integrators, taking these components and building out and figuring out the design, installation, commissioning, and deploying those systems within as part of your facility. Maintenance service providers, these particular vendors worked with us during the operation and maintenance phases, and obviously regulators who introduce requirements throughout the life cycle of a system or a facility that could change ways you designate security levels and some of the functional security requirements that you currently have, and probably would affect the levels, the target levels, as a specific system is in a facility and is in its life cycle. I wanted to put this slide out here just to kind of have an overview of the different components of a facility. So at the top, typically a 10-year life cycle span for a HMI or the server layer would be about 10 years. And that's what the end of life would start. Most vendors would start proposing upgrades by a 10-year period. Controllers would be 25 years. RTUs, PLCs, vibration monitoring, compressor control, those type of auxiliary systems would be a 30-year. And then IO modules and all those IO subsystems would be 35 years. So you can see from this slide, you see a spread of how the life cycle and obsolescence would vary across components and systems within a specific facility. And so security requirements, and these are integrated within a specific system at different security zones, or and these, how you address the life cycle for one component with a 10-year life cycle, for example, HMI, in relation to a PLC that has 30 years will be significant, because in some scenarios, you might want to, vendors might be proposing changes to controllers after a 25-year period. Meanwhile, with regards to the systems that they're controlling, they have a longer duration. For example, the RTUs, IO modules would be a longer duration. So some of these systems might have to be changed at the same time. So these are some of the lifecycle considerations to think about. So I wanted to kind of go through the different phases of a life cycle. So there's a specification phase where you looked at where our contracts are baked in with the restricted vendor lists, where we have different system service providers, component manufacturers that are specified and they're authorized to provide these. This is an area where security requirements are baked in. During the design phase, basis of design, detailed design. During the implementation, fabrication, during your FAT, you would have, these are areas in which the implementation phase would be done in a facility. Then you go onto your verification and validation phase, SAT, commissioning. Then facility is handed over to the asset owner, and then you get to your operations phase. There would be management of change as different upgrades and TARs, turnaround projects are put in place. And then your maintenance, management of changes. And then there's the decommissioning phase, which is an important part of. So this is the entire automation system lifecycle. You saw the 10, 25, 30, 35, and this is kind of a spread of what you would see in a specific facility lifecycle. Objective is to maximize the utilization of your system in a safe and reliable way. Increase your performance reliability. These are the objectives of lifecycle management: extending the lifespan of a system, maximizing your return of investment, even pushing it beyond manufacturer support dates. There are obvious benefits and bonuses provided to engineers for achieving this. Lower maintenance costs, reduce the risk of component failures. And so these are the key objectives of ensuring that lifecycle management is baked throughout a facility's lifecycle. Enhancing automation systems to meet the changing business requirements and challenges, introduction of new concepts, IoT, artificial intelligence. These are beginning to creep into facilities. And so how do we ensure that those new business requirements are being incorporated and taken into account when facilities are being maintained and operated. And we talked about that. So, and some of the challenges that large asset owners face during lifecycle management is that you have very long plant maintenance and shutdown intervals, and these limit the opportunities to make these security modifications and also operational business changes to a facility. I've been involved in, and led investigations where you've had active threat actors who are at play, but just because of these difficult TAR windows, a facility has to stay up, even though that there's a clear and present threat that has been identified. So these shutdown intervals can significantly impact, if not done properly, can significantly impact the business functionality of a facility and will impact production. And that goes down to even safety and also dollars and finances. Incompatibility introduced by software version drift. So you have, as the life cycle increases, if you are not constantly addressing upgrades, you begin to see a drift in the install base of your components, and especially firmware and version changes. Rip and replace to address obsolescence is very expensive and risky. You typically are dealing with facilities where you've had that drift over the years. They've kept these different components and systems in place without these frequent maintenance going on. And then at some points you want to rip and replace and find out that it is really risky, and it draws a lot of, it will incur a lot of expense. Adoption of IT systems with shorter life cycles. We all know that it's a challenge as we introduce these components and systems within our, we looked at the life cycle phases of 10 years, 25 years, and seeing how IT type systems, their life cycles are shorter, and how does that impact our upgrade process within facilities. Security requirements obviously need to be factored. And those are challenges impacting life cycle. Determining operational maintenance costs to measure return on investment is becoming more challenging. All right, so we jump straight into the security lifecycle objectives. From a security lifecycle perspective, looking at security lifecycle and automation lifecycle, facility lifecycle, what are the objectives of a security lifecycle? One of the first things that I wanted to mention here was that is used throughout the life cycle of an automation system. These technical and organizational security measures are baked in all the way from the design phase to specification phase, design to decommissioning. So I kind of put this out there that from a specification phase, security requirements are included as part of procurement and defining requirements so that SDLA development life cycles are considered, security requirements are baked in the development life cycle. During design, its systems are basically built secure by design. Managing security throughout the construction implementation. You have a typical facility during construction. Some large facilities could take up to, refineries could take up to 5-6 years to be built. And so you have these multiple vendors coming in and out. So security requirements need to be kind of considered and baked, and compliance to those requirements need to be checked and measured throughout those construction periods. During FAT and SAT, pre-commissioning. And then back to the focus area for our discussion today would be looking at the operational maintenance and decommissioning phases. How do we manage operational security there, and some of the depth concepts that we would need to kind of consider as we focus on these areas in the life cycle from a security life cycle perspective. Key concept to introduce here is a security level. That's just that confidence and assurance that the system is free of vulnerabilities and it's functioning in the intended manner. Risk assessments are typically done to define what those security levels are. I'll be focusing a bit more on the operations, obviously, and maintenance phase, which is the focus of this presentation. But risk assessments could be defined during the earlier phases or are supposed to be initiated during the earlier phases to determine what these security levels would be. There are three types of security levels that, that have been specified as part of the 1-1, 6443 1-1. One is the capability of a system. What does, as part of the build and the design of a system, or the integration of a component, and then the system integration, what do we expect that that specific system can meet based on the vendor's baking in of security requirements within that specific component. Target security levels, remember, part of risk assessments, a risk assessment's done for a specific zone, and a target security level is defined based off a risk assessment. And so as a facility is being provisioned, we kind of roll back into the next thing, which would be the achieved security level. So as part of commissioning, an assessment's typically done to verify that the achieved level, the target level is achieved, and that becomes the, that's parked in as part of the commissioning to define what the facility and the zones and the various conduits would have, what security levels, and maintaining that throughout the operations and maintenance all the way up to decommissioning. So target security levels are defined pre-operations, and then achieved security levels are maintained throughout the operations and maintenance phases. All right, just make sure I'm doing well on time. Security level, this is just straight out from the taxonomy from 1-1. So security levels are, you can see the different protection levels from 1 to 4, 1 being protection against, so if a security for facility or a specific zone is defined as an SL1, then the protection against, it's against casual or coincidental violation. And all this is determined off of risk assessment. So if a facility during the operations phase, if we find out that a specific zones, for example, ESD zone or zone that has ESD systems and PLCs and all of those supporting infrastructure, that could be obviously probably be an SL3 or an SL2 or an SL3. And then you would have other zones like the DMZ zone, or probably like the process automation network zone would be probably an SL1, depending on what assessment's been done and how your facility has been built. And that's talking about the different zones. I'll just quickly skip through that. All right, so I wanted to with this slide, I just wanted to talk about contrasting ICS lifecycle with the security lifecycle and putting them and seeing what those differences are. The automation lifecycle, system lifecycle is focused on extending the lifecycle of a specific system component or the facility. And the security lifecycle is focused on risk mitigation. So it's all based off of risk. So risk assessments are done, and based off of what they defined, based off the risk assessment, what controls have been defined that should be in place. That's the focus of the life cycle of security life cycle. The IACS life cycle is focused on reliability, and with security life cycle is focused on the protection of the system. Operational costs are significantly reduced. The intent is to reduce cost. When you're looking at this automation system lifecycle, it's all about return on investment. But from a security lifecycle, it's kind of really difficult to demonstrate cost reduction when you're introducing functional security requirements that obviously could impact expenditure. So just wanted to put this slide out there so we can contrast the two different life cycles side by side. And so from the security level life cycle, so the SLC is the capabilities security level is usually determined during the specification and design phase. The target security level is during the implementation and verification and validation phases. And then the achieved security level is usually measured during the operations, maintenance, and decommissioning. Right? And so we're going to look at this aspect of it. The achieved security level is the effectiveness of the countermeasure. So we define functional requirements and we want to ensure that we measure them during the operations phase of a facility. What capabilities have been defined? What's the target security level and how effective are those countermeasures that are introduced? Audit and testing intervals of these countermeasures and inherent security properties are done during this phase. Degradation of countermeasures would occur over time. So you have a countermeasure in place 2 to 3, 4 years later on during the life cycle of a facility, you find out that new weaknesses in the system, vulnerabilities, new exploits have been determined, and the security level of a facility basically drops. Your countermeasures that you've introduced, so if you're in an SL2 or an SL3, you find out that the countermeasures that you defined during the commissioning and you have been measuring to maintain the achieved security level, you find out throughout the life cycle as time continues to progress, those countermeasures degrade and become ineffective. Obsolescence also introduces a challenge. The expertise of attackers was seeing much more determined, more motivated, funded adversaries and resources that have been put to the automation space. So during the achieve security level in the operations maintenance phase, there are factors that we talked about, some of their factors. So let's say your facility is at an SL4 and operations, you're at the commissioning has specified your SL4, it's an emergency safety system in the safety system zone. It's determined as it's an SL4. You will find out that as the life spans, you move from operations, maintenance phases, back to operations to maintenance during TARS, you find out that the security level continues to reduce as time progresses and the life cycle of a facility continues to extend towards the decommissioning phase. And vulnerabilities and obsolescence are the key factors that drive the change of the achieved security level in that facility. Some of the challenges are large potential for achieved security level drift. So we begin to see that there is drift. Facilities, just talked about that. You have a facility that's designated as an SL2, SL3. As time continues to move on, you find out that that achieved security level has degraded, and then an assessment, and that's usually uncovered during assessments, security assessments. Monitoring of security vulnerabilities are achieved and requires significant effort. It takes a lot of effort to actually conduct these assessments. We had a lot of presentations here on testing system components. In labs, it's kind of easy to be done, or within controlled environments or the test environments. But in actual production, you're not going to get the business support or the operations support. Operation managers are not going to support active testing. And there are ways around that, but you are not going to be able to test system vulnerabilities as during the life cycle. The TAR phases are usually when they recommend, and these are kind of like 3 to 4 years between each of these testing phases. So, and we know that the current vulnerabilities we're dealing with are occurring on a much more frequent level, time period. New system vulnerabilities emerge faster than product suppliers and maintenance service providers can develop remediation. And we all applaud ourselves when we find new vulnerabilities with our PLCs, and we see the automation vendors and manufacturers playing catch up. But even when they do find patches and remediations for this, usually if you look at the recommendations, it's like, oh, you know what? Ensure that these other countermeasures are in place because we can't easily fix this vulnerability. Ensure that your system is protected, it's in a secure zone. It's the same thing, right? So it's not easy for the manufacturers to play catch up with fixing these vulnerabilities in our systems or components that are being used within these systems that even sometimes the automation vendors or product manufacturers aren't aware of. Certification. So there is obviously the industry has made ISO Secure has made a lot of effort to define certified components and systems, but it's a point in time. And as the facility uses these recertification well, ICS has done a good thing to ensure that sort of recertification is done at a 3-year window. That's really important. That's been feedback from the community to incorporate that, kind of tying on within the usual maintenance cycles for a plant or facility. Just making sure I'm good on time. I just want to talk to Tim just to figure out how long. I can't see a clock to work with. But I'll just keep going on. Incorporating cybersecurity in operation and maintenance phases. Usually where you would determine the controls that need to be implemented during the operation and all the way through maintenance and decommissioning will be as a result of a risk assessment. So you would want to ensure that these assessments are frequent. The scope of these risk assessments are kind of well-defined, and you have standards and procedures documenting that to ensure that they are considered. If not, you would find out that the maintenance would be done. You would have even short maintenance windows, or you would have vendors or operators, plant managers bringing these short maintenance support service providers coming in to make changes that would not typically be flagged in during the management of change process. So you would also want to introduce risk assessment during these phases to make sure that they're done. Also compliance phases, so the functional security controls that have been put in place, you would have compliance to that at a frequent, always also during, after maintenance phase and during operations, but also after decommissioning. I found out that I've been in facilities where you have the plant operations team saying, oh, we just took out, I'm like, identified a vulnerability with the system, and they're like, oh, we're no more using that. We've taken that off the system. And then guess what? It was basically taken off the asset list inventory, but the system's still plugged in somewhere on some network. So we want to ensure that assessments are done to ensure that systems are decommissioned.
So right. I just wanted to answer your question. We have about 4 minutes left.
All right. Critical success factors, slides will be available. Work very closely with your vendors to ensure that stakeholders are aligned with their approach to security throughout the life cycle, operation, maintenance, and decommissioning phases. Baking security requirements into maintenance contracts. Ensure you do have maintenance contracts, and ensure that security requirements are put in. Take a look at those contracts and ensure that you have your security teams write standards or policies that would address, will kind of bake into that process. Prioritize the procurement and strategic efforts to align your vendors in your supply chain, ensure that those expectations are defined. Develop clear policies, standards and procedures for operations and maintenance phases. Conduct security lifecycle assessments so ensure that you have these frequent assessments, risk assessments, compliance assessments throughout the security lifecycle during the operations all the way to maintenance and decommissioning. And about 3 more here. Account for the inclusion of functional security requirements in your budgets. Most times you want to introduce these requirements and everyone says there's no money for that. So ensure that budgets consider that when they are being provisioned. Avoid costly system upgrade by ensuring that you upgrade in a stepwise fashion. You just don't wait till the versions have exceeded. Ensure it's stepwise and you move along with your automation vendors. Reduce risk and increase availability through proactive maintenance. Increase cybersecurity considerations during obsolescence evaluation exercises, and so be baked in the process. A couple of references you can take a look at. Slides will be up there, and I think that that's really what I want to share today. I hope some impactful things for the asset owners and the facility and the operation teams to take a look at.